Welcome back. This is an Aleks training video on balancing chemical equations with non-interfering coefficients. So this is the first lesson on balancing equations, and it's something that you're going to probably get pretty good at because we're going to do a lot of these. When you balance an equation, all you're doing is saying that you've got the same amount of stuff at the beginning of a reaction that you have at the end. A chemical reaction can't create matter out of nowhere, and it can't make matter go away. All it can do is break the Legos apart into smaller Legos and then reassemble them into different combinations. You're still going to have the same amount of matter at the beginning and the end. So a balanced equation is showing you what is made and how many of each atom is made and what it started with and what it ended with. But you need to tell me how many of these little different pieces do I need to take apart so that I have the Legos sufficient to make the product. So what we're going to do is you're going to multiply each of these molecules by a number called a coefficient that just tells you you need this many hydrogen molecules to react with this many hydrogen molecules, and it will give you this many ammonia molecules. All right? So you're just looking for the same amount of matter on both sides. So my advice to you is that you do hydrogens last. Hydrogens are so tricky that they will often be the one that gives you the problem. I would do it last. I would do oxygens second to last. Everything else first, okay? So it doesn't matter. I've only got two atoms here. I've got nitrogens and hydrogens. I'll do the hydrogens last. I'll start with the nitrogens. On this side, on the left side, I see that there are two nitrogens. This subscript tells me I've got two of them. Remember, subscript is telling you what's in the molecule. Nitrogen is one of the 7 diatomic molecules. If you remember, we had oxygen, nitrogen, hydrogen, fluorine, chlorine, bromine, and iodine. And those are all diatomic. Nitrogen's one. Hydrogen also is one. It's an H2 in the free state. So hydrogen reacts with itself to make a molecule. These guys are going to break apart. The bonds are going to break apart and then reassemble into ammonia. But if you look here, if without it being balanced, I've got 2 on this side but only 1 on this side. When I use all of my nitrogen, I will end up with more than 1 molecule of ammonia because I have 2, so I can make 2 molecules of ammonia. But it's going to take more molecules of hydrogen to do that. So let's start with this. I've got 2 on this side. In order to show that I'm going to need 2 nitrogens on this side, I can't put a subscript because I can't change this molecule. A molecule of ammonia is NH3. So I can't change the subscript. All I can do is use a coefficient. So I'm going to multiply the entire molecule by 2. So you'll end up with 2 molecules of ammonia at the end. So I've got 1 molecule of N2, and at the end I'm going to have 2 molecules of ammonia so far if I've got 2 to 2 fixed. When I multiply this 2 by ammonia, I don't just double the nitrogen, I also double the hydrogen, which here is 3. There's 3 hydrogens in the original molecule. When I double that, there will be 6 hydrogens in this on this side now. So if I have 6 hydrogens, I have to go back to the other side, and I've got 2 on this side. How do I get 6? Well, the only thing you can do is multiply, and you'll multiply the first coefficient by 3. So let's check out and see if we've got the same amount. I've got 2 nitrogens on this side. I've got 2 nitrogens on this side. I've got 6 hydrogens on this side. And I've got 6 hydrogens on this side. I have 3 times 2 and 2 times 3. So I have 6 hydrogens, 6 hydrogens. So that's balanced, meaning that I've got the same amount of matter on both sides. Now, this is a simple example. It gets way more complicated. But you start in the same way. You look on one side and move it to the next and go back and forth until everything is balanced. All right, I hope it helps.